So, hello everyone. Hope you're having a great JSpring so far. Thank you for being here. It's the last time slot of today. You could have chosen an early beer, but you are here. I appreciate that. Maybe I shouldn't have mentioned that. This loading spinner here, it's a bit annoying, isn't it? You want to know what is about to come, but it just lets you wait. And most people in the world don't like that very much. And most developers in the world don't like to create things that most people in the world don't like. But still, we as developers create slow applications from time to time. And I did it myself as well, recently. And that's a shame, because it was a really important application. At least to me it was. And let me explain it to you by telling a bit about myself. My name is Roseboom. I'm a freelance software developer from the Netherlands. Sometimes companies hire me to work for them. I've been doing that for over a decade now. More recently, I went into public speaking, as you're witnessing now, more like last year. But on top of that, I have, probably like a lot of you, regularly the best idea ever. And my most recent best idea ever that, was the slow application that I was referring to, is a FunFactStore. Now, let me show you that. Here, it's a store where you can buy fun facts, and I want to share one that I acquired myself in my own store. So, the fear of long words is called hippopotamonstrosesquipedaliophobia, and I think that's a really cool fun fact. I really love the guy or girl that came up with this fact. And also, it serves you a bit, because we are here in a nerdy talk, of course, and probably the entire day is full of nerdy stuff. But when you go home and your spouse, friends, relative ask you, okay, what did you do today? If you tell them the nerdy stuff, well, honestly, they don't care. But maybe with this fun fact, you can at least tell them something that they find interesting. The only thing you have to do is to remember the word. But, well, that's the detail. Of course, in a fun fact shop, you can buy fun facts. And this is my great idea. So how does this fun fact store look under the hood? It has a relational database and a server app talking with that, and that, well, serves some client app. It's a familiar setup, I think. We all have applications like this. Now, in the first part of this talk, we will focus on the client app. The client app here is a browser rendering HTML based on time-leaf templates and styled a bit with CSS, which concludes the first part of this talk, where we saw some details of the client app. And it leaves us some time to focus on this part, the server app. How does this server app communicate with the database? Now, in my FunFactStore, the database is Postgres, but I grayed it out because it's not really relevant for the talk itself. It could be Oracle, MySQL, or whatever you use, if it's a relational database. The server app here runs on Java 24 with Spring Boot and Spring Data JPA. It's also, well, very well-known, very convenient, but it comes with some challenges. First challenge, manage the database connections. There are some pitfalls that could hurt your performance. Second one, once we establish that connection, we have to let the world of tables, columns, and database rows talk with the world of classes, fields, and objects. Well, there are some performance pitfalls there as well. So today I will talk a bit about the challenges in database connections, and after that, the JPA challenges. So to start with the connections, how do we get a connection? In our app, our server app asks a connection from the pool, the connection pool. Spring Boot by default uses Hikari, which is quite a good connection pool. The connection pool itself gets its connection from the driver manager, and that uses a driver to get the connection. Now, why do we use a connection pool? We could just ask the driver manager directly for a connection, because it's faster. And, well, I can show you that in a very small test, because, well, we can say that it's faster, but let's just try it. I wrote a connection timer test here, and basically what that does, it spins up Spring Boot. It has two tests, and it calls a connection timer. The connection timer connects 1,025 times. It ignores the first 25 times for a JVM warm-up, stuff like that, and then it prints some statistics about the remaining 1,000 attempts. Now, I have two tests here. First uses the get connection of the pool, so the one that your Spring Boot application just uses. The second one uses the same underlying database, but it asks the driver manager directly for a connection based on the properties of the Spring connection pool as well. So let's run the test and see what it brings me this time. So here, the Hikari pool, we can get 1,000 connections in a little over a millisecond. And when we directly ask the driver manager, it's like over 5,000 milliseconds. So using this connection pool pays out. It's in this simple test 5,000 times faster. And I run this test multiple times. It's always this order of magnitude. And of course, well, if you have a different database setup, it may vary, but this type of difference, that's not uncommon. So let's zoom in a bit onto this connection pool. And we can do so by set the debug level of Hikari, set the log level, sorry, to debug for Hikari and restart our FunFactStore application and then see what we can find out about this connection pool. Well, we can find out a lot, and well, this is nice, but zoom it for now, because maybe you're not interested in all the fast keys that I could have used. Here's a lot of information about our connection pool, but I want to zoom in into two things. The maximum pool size, which is 10 by default, because as you see, I didn't configure anything, meaning, well, I can have, for the max, 10 connections in my pool. The minimum idle is 10, meaning, well, I fill the pool on startup right away with 10 connections. Now, if all those 10 connections are used, and the next user comes in, then what happens? He's faced with such a loading spinner. He has to wait until the next connection is available. So in order to prevent that, we want to use the connection as short as possible. So give it back if we don't need it, and only acquire it just before we need it. But how can we know when we need it? So in my example application, we had a get connection, and it has a close. But in our Spring Boot data application, we don't have that. It's abstracted away. So for example, if I show you the shop controller that basically corresponds with this endpoint. You see here we have a last purchase date. It corresponds with this endpoint. Then we see it enters the method. Then it calls the shop service to actually achieve the last purchase date. And well, there's no get connection or close connection. And that's because we delegated that to Hibernate. Hibernate gets the connection when it needs it and returns it to the pool when the transaction is over. But there are some pitfalls there. And let's verify that by checking on it. But by default, we don't log when a connection is acquired or when it's returned. So how can we know? Well, for this purpose, I added a timer logger, and you can use that yourself as well. I will share all the code you see here afterwards. And basically what it does, it adds a metrics tracker factory to our data source, which is the Hikari connection pool. And that does only two things. It prints it when a connection is acquired, and it prints it when a connection is returned to the pool, together with how long it is used. So exactly what we want for this demo. So let's put the log level to debug for that, and do the same for the controller and the service, so we can follow the flow of the application. For our convenience, I created a test that just calls the endpoint, which is this one. So it just does a GET request, and then run the test and see what happens. So here it is, and here we see the results. So we're entering the shop controller here, and then we go into this transactional method. Connection is acquired, we check if it's a criminal. Then a last purchase date is get, then it returns to the controller, and only then the connection is returned. That's kind of a pity, because it is not returned after this transactional method, it seems. And that's a pity, because here we sent an email to our CEO, because we're happy with this potential customer. But we don't want to do that while we have this connection leased. We want to return it to the pool. Anyone knows why it's not returned right after the service method here?
Because of the transaction?
No, it's not because of the transactional annotation. It's actually a common configuration mistake in Spring Boot applications, and it warns you also for that. So here it says Spring .jpa.open in view is enabled by default. So if you don't specify it, open in view is enabled. And it means if there is a transaction, then I keep it open until all the views are rendered. So you can interact with the database in your views, in rendering your views. But, well, we don't want that, and it's a bad idea anyway. So let's put this to false. And I think it's kind of an historical mistake of Spring as well, because this, let's make it Spring. This is logged with a warning level as well, since later versions of Spring. So they actually thought, okay, maybe this is not a good idea, let's log it at a warning level. And now see, when we change that the connection is returned right after the transactional method, exactly like we want. So now we can email our CEO without having the connection still leased from the connection pool, and that saves us a lot of time. Now it's only 270 milliseconds instead of the almost 700 that we started with. So that's cool. We got rid of it when we didn't need it. Now, let's focus on the other end. Because when did we acquire a connection? So just before check if it's a criminal. So here. And yeah, we might think, okay, this makes sense because it's a transactional method. I told you, well, Spring or Hibernate gets the connection when it needs it, but Hibernate is a bit smarter than that because it only acquires the connection when it needs it. But still here, the connection is opened, is gotten from the pool. So anyone knows why? No, well, if you're confronted with such an issue, then, well, let's dig into it. I think that a very good idea is to put the root level to debug, and then let's find out if we can see why Hibernate is doing this. So we rerun the test, and then, well, you can imagine what happens. An awful lot of things are locked, but yeah, we don't know where it is, so just log everything. And then let's see where it is. Here we have check if it's a criminal. Here the connection is acquired. And just set autocommit to false. And that is what Hibernate does. Hibernate wants to be absolutely sure that autocommit is set to false because it wants to control itself when stuff is committed. That makes sense. And it can only be sure by just, at the start of the transaction, get a connection and set autocommit to false. So that's a pity, because of this, again, we have a call to an external system while we release the call. Now, we can solve that by setting autocommit to false and tell Hibernate that we did. And that is, again, a good practice to do. So let's do that. And basically, I do it like this. So here I tell the Hikari connection pool that autocommit should be false. And then with this line, we tell Hibernate that we took care of that ourselves. So provided disables autocommit. However, from Spring Boot 3.2 and later on, it does that automatically if it finds out that you did that. I use Spring Boot 3.5 here, so I don't need to do this. Because, well, we need to tell Hibernate, but Spring Boot does it automatically. So in my case, I don't need to do that. But if you don't use Spring Boot at all or an older version, then you have to tell Hibernate, okay, Hibernate, I did it myself. So now let's see what happens. Here we have check if it's criminal. That's a call to an external system. And we didn't lease the connection. And then here the connection is acquired. But yeah, that makes sense because we communicate with the database. And it's used for only 13 milliseconds, which is a great improvement. Just by changing some configuration, we went from almost 700 milliseconds to 13 milliseconds. Now, there is a thing here, because we check if this user is a criminal with the external system by feeding it our own username. That might not make sense, and we misunderstood the API. It should be the email address. So we can find the email address, of course, in our system. Let's find email by username and, well, or else throw. And let's use that one to check with the external system. But, and, well, log, no, not this. We want to log that this happens. So find email. Now, you can imagine the problem that is going to happen here. Because in order to get the email address, we need the connection. So that makes sense, but then we call the external system while we're still having the connection. And we're back to 230 milliseconds. Now, a common solution you see here is that you create an additional service, and you move this method to that service, and then so we remove transactional here, and we move that to the other service, we move this one to the other service, and then we got some kind of ping pong between the artificial other service. That would solve this problem, but sometimes I prefer to use a transactional template. The transactional, this one. And what you can do is you can execute code in a transaction by feeding it a lambda. And you keep the flow, the reading flow of your code. So if we do it this way, and again, recall that I removed the transactional here, because otherwise we create one transaction that wraps the other transactions, and we don't want to do that. So here we see that we acquire the connection, then we find the email address, and then we return it. We call the external system, and then again we acquire a connection. So that way we are way more efficient. And well, that concludes the part about connecting to the database, where I showed just some things that I've seen wrong the past year quite often. So let's wrap up. Pooling is fast. We saw that in the test. And we want to lease the connection as short as possible. And we want to lease it as short as possible to give it back the first moment we don't need it anymore. And well, if you use Spring Boot, please check this parameter, because that helps you with that. This one helps you to get it as late as possible. And for the same reason, be careful with adding read-only is true to your transaction. Because in my example, you might think, OK, this makes sense to do, because we don't modify any data. Please annotate it with read-only is true. But what will happen then is that Spring will ask the connection to Hibernate and set read-only to true, being the connection opened at the first statement as well. So then basically we have the same problem as auto-commit here. Don't do external calls during a lease, because that's a waste. We don't interact with the database. Don't keep it open then. And well, a transactional template, I think that is a reasonable alternative to ping-ponging back and forth between an artificial created extra service in order to solve this problem. So, before hopping on to the next topic, I will be very generous and I will just buy you some fun facts. So you have something to tell at home as well. Shark predate trees. That's maybe a better one to remember to tell all your friends at home. And it's actually true. Trees are around for 350 million years on this earth, and sharks are already 400 to 450 million years here. So that's a cool thing. And, well, since I'm in a good mood, I will buy you another one. Rats have the ability to laugh. Actually, you can tickle rats, and if you do that, they will laugh. So remember those three things, then you have something interesting to tell at home. But for now, we will continue with the nerdy stuff. Because now we set up the connection. Then we have a world of rows and a world of objects. How do they talk with each other? Basically, JPA is a standard describing that. I think as of today, we should call it Jakarta persistence, but it's well known for JPA, so still mentioning that one as well. It's a standard describing how we let the world of tables, columns, and database rows talk with this world of classes, fields, and objects. Hibernate is just an implementation of that. Sometimes the names are intermixed. So JPA and Hibernate. JPA is a standard. You need an implementer. Hibernate is probably the best known, and also the default. If you just use Spring Boot JPA and you don't pick your implementer, then it's Hibernate. My FunFactStore uses Hibernate as well. So how does that look? Let's go to the code. And first we will open an entity. And an entity is a class that is mapped to a database table. You can recognize that here with entity. And, well, you might expect a table name. You can specify a table name, but I didn't do it because I follow the naming convention. And the naming convention of Spring Data here is to translate this camel case to snake case. And since I do that, I don't need to specify it. Same holds for fact. I could specify a name here, didn't do it, because the column name is just the same. And here with explanation, it's also mapped. Don't get confused by the missing column annotation, but I didn't specify that because I just follow all the defaults. It's nullable, the name is the same. And the same here for a join column. I didn't specify join column because the convention is the field name underscore and then the ID of the primary key that you are referring. And that's exactly what I do here. Now, an entity is required to have an ID, but since all my entities have an ID, I abstracted that away in a map superclass here, and here is the ID field. Now, this fun fact itself had basically one method, and it is the sanitize method. Because, well, I want to protect my users, and it could be that by incident there are fun facts that have bad words like boring and stupid. And of course, I don't want to expose my users to those terrible words. So what I did here, I have a method that sanitizes the fact and the explanation. And sanitizing here means replacing those bad words with asterisks, and if it doesn't end with a dot, let it end with a dot. And this method, I will call that here by basically fetching just all the facts and then sanitize them. Now, Hibernate generates SQL under the hood. And I want to look into that SQL. And you can do that by setting the SQL logging level to debug. Basically, like this. Now here, for our convenience again, I created a test method to call this. Now I expect some kind of select all here. And that is basically what happens. So I have a select all facts, and here I have fetched 10 facts. So that is this one, select all from fun fact. But then here, I have 3 additional selects. Now, I think they correspond to this relation, but why are they fetched? Anyone knows that? Exactly, exactly. What happens is, when you fetch all the entities here, then all those columns are mapped to something. And this relation is mapped to a proxy, to this app user. Now, a proxy can stay a proxy, or Hibernate can replace it with a real thing immediately, depending on the fetch strategy. But the thing here with many-to-one is that the fetch strategy by default is eager. And it means I want you to replace this proxy immediately with the real thing, which kind of is a pity, because I don't need that anyway. So for many-to-one and also for one-to-one relations from the owning side, it's very good to specify that and tell it that I want to lazy fetch that. Now, my next question, there are 10 facts, but there are only 3 selects here. I would have expect maybe 10 selects, because there are 10 facts, they all have an admin. It's not a nullable field or whatever. Anyone knows why is that? Caching? Yes, yeah. Yeah, no, well, it's the first, it's true, it's caching is the persistent context, also called the first level cache of Hibernate. Basically, Hibernate holds a cache for entities, and that is bound to the transaction. So what it does, if it finds that a proxy with some ID is already there, then it doesn't, again, do a query, because it already has that thing, and it replaces that. And that has 2 upsides. The first one you can think of, because it's only 3 queries, and not 10. So basically, we can conclude that the 10 facts here have 3 different admins. So less queries. That's very good. But the other one is more subtle, is that because of this, we have the guarantee here of a repeatable read. So if you're talking about isolation levels, then you could still have isolation level read committed of your database. But because of this persistent context, Hibernate guarantees some kind of application level repeatable read. So you have the benefits of the repeatable read here, while still having read committed on your database level. So that's more subtle, but still a very nice feature of this persistent context. Now, we didn't need it, so I specified it to fetch it lazy. And if you do that, and again, we rerun the test, then, well, it behaves like we want. It fetches all the facts, just the same here, but then it leaves the proxy just the proxy. But of course, yeah, the world changes. Sanitizing here didn't need anything from the user, but now we have this new feature where the bad words are not just a static list of bad words. They depend on something that is encapsulated in the logic of the admin here. Now, if we use this method to sanitize, and we rerun the test, then something changed, because we need the admin entity now. So if we look at the queries here, sorry for that, we fetch all the fun facts, then it told us, okay, we fetched them, but then while sanitizing, it fetches them right away. And now it's not bad that it fetches them, because we need them, but it fetches them one by one. Now this is called an n+1 problem. We just had an n+1 problem again, and it means I have one select just to select the thing, and then I have n other selects being proportional to the result, to the size of the first result set. So n here is 3, but it's proportional to this result set. Not equal, but proportional. And, well, that's not what we want. So if you know that you need that, those entities, then please specify that in your query. Here we have find all with admin. Now, what is find all with admin? It basically does select all from FunFact, but it join fetches the admin, basically telling Hibernate, okay, well, just fetch that, but I need the admin, please join it with it. And then the result of that query is that that it joins the app user, and then while sanitizing here, we don't need the additional selects. So that can really save a lot of time. Again, recall that here you might expect some save all method or something. Something like this. You see that a lot in code, but we don't need that. The objects here are, the entities are managed by Hibernate, so at the end of the transaction, it finds out itself what is changed, and it updates the database. And well, I can prove that by those update statements. And that's really a great feature, I think, of Hibernate, because here we fetch all the fun facts, then we call some modifying method, but what that method does, we encapsulated it in the fun fact itself. So using object-oriented programming, we encapsulated that. We don't need to keep track of what is changed. Hibernate does it. When the transaction ends, all the things are updated that needed to be updated. So that's very cool. But sometimes we see that entities are also used for reading purposes, just reading it. Yeah.
Updates 10 times. Does that mean that all the entities contain bad words?
I did it artificially by adding the dot. They don't. You are right. I wanted to demo that they actually update, and my fun facts don't end with a dot. And that is why it updates. But you are right. If I skip that line, then probably it wouldn't update because my fun facts are nice. They don't contain words like boring and stupid. Yeah, that's a good question. Thank you. So this is very nice. But when we use these entities for reading, then it's quite a different story. So that's what we do here. We find the purchases for a user based on a username, and then based on that we create a fact DTO, which has the purchase date here, the fact itself, and the email, the support email. So basically it corresponds to this endpoint. You see that? Purchase date, support email, and text. Now, again, for our convenience, I created a test. So let's enable debug level for this one, and just fire the test, and see what happens. So here it has one select to get the purchases, and it does a join here, but only to filter on the username. And then, well, for purchase date, it has enough, but here it fetches the fun fact, as you see, and then it has to fetch the admin. Then it fetches the second fun fact, and apparently, as we just saw, this has the same admin. So it's already in the persistent context, no need to fetch another admin here. Then it fetches the third fun fact, which apparently has a different admin, so it fetches that. So again, we have our n+1 problem here. And we could fix that the same way as we did in the previous example by join fetching them. That's an improvement. That would be better. But we don't modify entities here. And added entities, they excel when stuff is changing. If you don't change things, you are way better off doing a direct DTO projection. And let me show you that. So instead of finding those purchases here, we do a direct projection. And this is JPQL. And you can just post the constructor of the fact DTO. That's the same fact DTO as you just saw. It's just a record containing this stuff. And we get it directly. So instead of fetching all of the entities with all those columns, we just fetch this. Now, let's use that and rerun the test. And see, we're only back to one select with some joins. Now, this DTO projection is based on JPQL. And the JPQL has some advantages, namely that we can talk in terms of entities. So, for example, if I do stuff like this, it tells me, hey, this is wrong. And even my Spring Boot doesn't start for this. So that's nice. But if you want to use specific features of your relational database, then you're stuck with native queries. You cannot express that in JPQL. But you're not lost. If you use Hibernate 6, then you can do almost the same with this constructor projection. It's a feature they added in Hibernate 6. You cannot do it. This is not according to the JPA standards. You cannot do it in Hibernate 5. But you see, this looks almost the same. We don't have this new, because this is, well, just a native query. But those selected fields, they match the native record here, which is good. Now, if you use Hibernate 5, then you're still not lost, but you need to use an interface-based projection. It's almost the same native query, except I have two aliases here, because they have to correspond to the interface according to the Java Bean convention. So naming is important here. Now, this is way superior to fetching the entities and mapping them to DTOs. Also, maybe you use mapper frameworks like MapStruct and, or something else. And I think MapStruct itself does a very good job in translating objects from one type to the other. But yeah, you don't need to do it here. It's superior to fetch it direct. You also save yourself a level of indirection from MapStruct that you potentially have to dig into when stuff goes wrong. So that concludes the part on JPA. And let's wrap it up. Add fetch is lazy, too many to one and one to one. I think it's kind of an historical bug that this is not the default, but now, well, you cannot go back because stuff breaks. If you need to use them, use join fetch, but only if you want to manipulate the data, because otherwise a DTO projection is superior. So, next thing. By the way, I see you taking pictures. Also, the slides, I will share them. So, next thing, JPA mappings, my order of necessity. JPA is way bigger than just the mappings, but the mappings have two things. They sometimes cause performance problems, and you can choose not to use them. And they are often the reason that people, well, are a bit mad about Hibernate or JPA. So, the first thing, the mapping of tables to classes and those fields, well, I love that. It's very good. I use it. The use of many-to-one, I showed you in this example. It gave me the opportunity to encapsulate code, well, that was not possible if I didn't have the many-to-one relation from the FunFact to the admin. But still, if we just map the foreign key column with a simple long, it is simpler. One-to-many, it can be convenient if you want to cascade behavior, but, well, it also can be a performance problem because you don't control the size of the child list. And that can be rather big. And the most efficient way to map a one-to-many relation is to map it bidirectional. So you have to map the one-to-many side as well. Then you are responsible of keeping them in sync. And if you have to map the one-to-many anyway, maybe you could stick with the one-to-many. Yeah, with the many-to-one, sorry for that. And the last one, many-to-many. I have to admit that I never use the many-to-many annotation, but of course I have many-to-many relations. Anyone spotted the many-to-many relation in my demo application? From user to FunFacts. But I mapped a join table and I named it purchase. And that gave me the opportunity to give it a descriptive name. And it also gave me the opportunity to add some property to that, the purchase date. But even if you don't want to do that, and if I just have a join table, then, well, I prefer mapping the join table instead of the many-to-many annotation. It's just simpler. Now, tools. A lot of things can go wrong. So aren't there any tools that can help us? Well, there are. First, JPA body. It's in the IntelliJ marketplace. And, well, 1.5 years ago, JetBrains acquired it, so it works seamlessly with IntelliJ now. Those configuration things. Aren't there any tools that can tell us, hey, dude, you configured this wrong? Yeah, there is. Hibernate Persistence Optimizer. It's created by Vlad Mihalkia. You can also check him. He's a legend in this field. And I can quickly demo how that works. So let's roll back everything that we did. And enable this one. So basically, what it does, it runs performance. It runs a test here against those configurations. It will fail because I have problems in my code. But not only it will fail, it will also tell me what went wrong here. So let's find here it is. So I have some critical issues, and I rolled back the code. So one is familiar for us. It tells me that the admin attribute in the FunFactStore is fetched eager. And then it tells me a bit why it's wrong, and it also has a link to more documentation on why you shouldn't do that. So that's very convenient. I like to use that too. Last tool, Gatling. Gatling can be used for load and performance testing. And how it works, it has a proxy recorder, so you can configure your browser or your app or whatever to guide the traffic against the proxy recorder of Gatling. Then it creates Java code or Kotlin or whatever you want of what you did. And then it's, of course, just what you did. But in the code, you can easily change your single user for 1,000 users, or 0 to 1,000 users in 20 seconds, or in 30 seconds. And it's really cool, I think, to reproduce load. Now, last thing, the FunFactStore, Dreams. We started with this FunFactStore. It's a really great idea, and it was with us all the time in this talk. So what are my dreams and ambitions with this FunFactStore? So first I thought, okay, this is a great idea. Maybe it can make me a millionaire. That's well, you hear nice things about being a millionaire. Should be doable. But then I thought, okay, this application is really nice. Maybe I should raise the bar a bit. Maybe I can win a Nobel Prize with it. I think medicine would be a good category, because fun facts, they make you happy, and what is a better medicine than happiness? Should be doable. I heard they are awarded in October. Should be doable this year, I think. But then I thought, okay, maybe this application even exceeds the level of the Nobel Prize. So I can raise the bar even more. Maybe this application can help me to serve you in talking about performance problems. And, well, I hope I did a bit of that, at least today. I thank you a lot for your attention. You can scan the dinosaur for code slides and my LinkedIn. I'll be around. I love to talk with you about this stuff or anything you want to ask. And thanks for your attention.